All right, midterm Friday. Come early if you want. I was here at 7. I'll be here at 7. You don't have to come that early, obviously, but if you want more time and you have something after, after this class, then you can come early if you want. We'll talk about it after we go over the homework. 52, 56, and 66. How'd they go? Good? They went good, then you're pretty set for the exam. Doesn't get a lot more difficult than this. Maybe a little more variety than just vertical. This one said 52 says find the resultant. What do we do first? Oh, can't see it. Well, that'll take a hot minute. What do you want to chat about until we wait for that? It is.
Might snow.
And snow, yeah, so I was gonna bring that up because Monday looks like it could be down to the valley floor. So I'm like 40 miles south, so most of the time I don't get it and this place does get it. But sometimes it flips over and I get it and this place doesn't, so.
Where are you at, by the way?
I am south of Oregon City, Beaver Creek, Malino,
My
Malala.
my girlfriend's parents are
Where?
Redland.
Oh, Redland, yeah. I am further south than that, but in that general area.
I know it gets good.
that far.
Huh?
Yeah, that far. Is that far south?
Oh, yeah,
I know you.
50 minutes, man. So it's a drive, but I don't know. I leave early enough that I don't have to deal with everybody.
So chill.
Yeah. So it's not that bad. Are we up? It's so dark. You want to try the lights off? You're gonna fall asleep if I do. Can you see it? See it okay? Yeah?
Yeah.
All right. All right, so it did say find the resultant. Did it say with respect to something? Or did it care?
The location.
They only gave us 1 point.
Yeah, just you only gave us 1 point. Exactly.
Location.
All right, let's do it today. What do we do first when we see this kind of problem and it says find the result?
Find the area.
Yeah, concentrate that distribution. So the way we concentrate the distribution is to find the area of the distribution. So, yep, 1/2 base times height is area. 1/2 base is 9 feet. Height is 8 kips per foot. 1/2 of 8 is 4. 4 times 9 is 36. All right. Doing it in my head's not a great idea. Where do we apply it?
1/3.
Yeah, so 1/3 from the 90, 2/3 from the pointy end. So it's like in here somewhere. Now that's gone. And all the distribution is gone. So concentrate those distributions. If they're complicated, like, a rectangle and a triangle, just break it up into shapes that are easy. Don't try to do super complicated shapes. You could get a shape that's like, this. Just break it into 2 triangles. Do them separately. 1 there, 1 there. It works. All right, what's next? Sum the moments.
Yeah.
So pick your spot, sum the moments. I'm going to redraw the beam, but you don't have to. Especially on the test, you do not have to make new drawings. Just use the existing drawing. Put your notes on that. Save time. So, moments a day. $36 times. Yeah, so it's 1/3 of 9, 369, 3 feet. Rotation. Yeah, rotation is clockwise. That's how we get the sine of a moment. Sine of a moment is rotation. Sine of a force is direction. The force points down, it's negative. Force points to the right, it's positive. A moment, the sine of a moment is from their rotation. You could have a question like that on the test. How do you determine the sine of a moment? Like, think about it, right? It's rotation. All right. What else? 5 kips times 13 feet. Rotation. Negative. That's going to equal some moment at A. What'd you get? Yep. 173. It's kip feet, not kip per feet. Don't do that to me on the test, because I have to take a point from you.
Did you say it? Yeah.
Yep, either way it works. I just can't say that very well. Feet kip doesn't roll off my mouth very well, but kip feet does. Yeah, it doesn't matter. It's a multiplication.
But it's not. Kid.
And it's not kips per foot. No, it is not. Yeah, these units are being multiplied, right? And then we just add them, so the unit doesn't change. The time we see kip per foot is when we see the load curve. That's when it's given kip per foot. So those are the subtle differences that make a big difference when we're working problems in the future that are really long, and we're trying to get the units to cross out. And you put in like kip per foot for a moment, it's not going to work out in the strength of materials equation. The units are going to be like, what's wrong? Why isn't this working? So, yeah. All right, 173, and that rotation is clockwise negative. And it is here. Correct? 173. All right, now what do we do? Yeah, we have to collect the forces there too, right? So we do the moment there, that's the rotation. Now we have to collect the forces at that same location. Yeah, so it's 36 down and 5 down. Making a total of 41K down. Yeah, so the resultant magnitude's 41. I mean, that's what it is. The moment just tells you where it's at, like how far out it is. So how do we know whether it's this way or this way? The 41? Of what?
Of the results.
Of the moment. So we know which way to move the 41. Could the 41 be out here? No, why not?
It's off the board.
Well, it can be off.
Rotation.
The rotation doesn't match. We have to match this rotation. If I put 41 out here, I would make that kind of rotation, which is opposite. So it does not go out here. It's got to be out here to make the same directional rotation. See that? It's a big kind of concept because, you know, if you end up with a vertical problem, you got to know whether to move it up or down. The moment is telling you where to move it. The moment rotation. So 41's got to be out here. And then how far? Distance equals moment divided by force. Moment is 173 kip feet. And the force is 41 kip.
2,135.
Perfect. D equals 4.2195 feet. Good. Perfect. So R equals 173 kip feet. Vertically downward, I might put that in there. 4.22 feet right of A.
Yeah, isn't it 41 kips?
Oh, shit.
Okay, so-
Good catch. That was the moment. What am I doing? That was a test. Yes, it is 41 kips.
Scared me for a second.
Yeah, I was moving on in my head. Guilty.
I mean, it's like, I guess easy to logically think about it right now, because it's like the force is that way, but.
Yep.
You're saying where it's vertical and you're like, it's easy to get your legs mixed up.
It is, and especially if I make you do it at an intermediate point. Like if I made you do the moment here. Like really close to where the resultant comes to. Like how, where's it go? The moment tells you where it goes. So. Yeah. The other thing you can think about just logically, and it's good to like just think logically, right? Here's the load, here and here. The resultant effect of that is gonna be in here somewhere. It's gotta be, right? There's no up force, it's all down force, and it's all between the supports. This beam is feeling a deflection like this, and it's definitely feeling a resultant that's on the beam, kind of centrally located. Right? So you can look at it logically as long as there's not too much going on. If I added, forces like this, now you can't really like, it could be anywhere, really, depending on how big these are. But a lot of the simpler problems, man, just look at it. Like, oh yeah. Like this one. Logically, where's the resultant going to be?
It's gonna be one.
This is 300 pounds per foot. This is 60. It's smaller, but it kind of has a bigger area. This is going to be a load here, a load here. The resultant's going to be, I don't know. Yeah, probably 10 feet, approximately 10 feet in there somewhere. Maybe 11 closer to the 60, depending on how big that gets. So you can look at it kind of logically and say, oh, resultant should be mid-span somewhere, right?
You're at 60 feet per foot.
Glitching.
Yeah, it's a kind of word.
Much better. All right, this one says find the resultant, same problem, same kind of problem, right? What do we do first? We have this down now.
In the distributions.
Yep, concentrate distributions. So there's gonna be one here. How big is that?
600.
600, 60 times 10. And then this one. Yeah, half the base is 3. And times the height, 300 would be 900. So now I'm just starting to do things, right? Not show the calculations completely. All right, where do you want to do the moment?
A.
I don't. Let's do it somewhere else. We probably all did it from A, so we'll do it a day. Some moments a day.
They just got me trained.
I know it. I know it. Yeah.
I see that little triangle and I'm
Right, right. Right. All right, so we got 900 times what? 2. So 1/3 of 6 is 2 feet. Rotation. Negative. 600 times Yeah, it's me, 6 plus 4 is 10, plus half of this, 15. Negative. What do we get?
10,800.
1,
18,000. Or no, excuse me, 10,000.
10800. Yeah,
Pounds, feet.
yep. Foot. Pounds.
Negative.
Negative rotating clockwise. Excellent. Now I'm just gonna draw point A this time. Save a little bit of time.
£1,500 going down.
Yeah, so then we collect our forces. 1,500 pounds. That's the 900 plus the 600, right? We move everything to the point where we did the moment. That means that out here somewhere is going to be the resultant of 1,500 pounds at some distance. And we can get the distance from the moment divided by the force.
Divided by 1,500. 7.2.
To what?
So you said 0.2. Oh, excuse me.
So 20? 7.
7.2 feet.
Okay. So
Yeah.
add the 0 because precision is going to be part of the exam. Numbers come to you, all numbers come to you accurate to 2 places. So in your answers, make sure you got a unit, make sure you're to 2 places in your final answer. So I don't have to like get you. Excellent. Yep. So this actually, that works as a solution for me, right? Showing the distance and R. Maybe I wouldn't have that on there, but you could do a little diagram showing where R is. That works too, if you don't want to write it out. These are definitely the kind of the easier problems because they're vertical, right? We haven't had to deal with a horizontal force. So, yeah, the more difficult one is 66. This one will take it'll take more time. I don't know if it's more difficult. It'll definitely take more time. I have like the full rainbow of colors now, so I'm super excited.
I need to get one of those pens that has like different colors on it.
I know, I used to have one of those. And I liked it. Like you can just toggle through the colors.
I had one.
Except I don't like you working in pen. That's the problem with that. Anyway. Okay, this one says find the resultant. Gives us 0.0. No distributions, so we don't have any of that stuff to do. But what should we do with these angled forces? Turn them into their components. Yes. So when you see angled forces, just get rid of them, make life easy, and put in their components. And their directions. And I like to put them in where I can see which way they're pointing from the point where they act right here. So this one component is here, this X component is here. So then you have to find them. So I need some notation. This would be the Y of the 15. This would be the X of the 15. This, what do we do with this 12 and 5? Yeah, get rid of it, find the angle. So the angle you're going to want is the angle to the horizontal. That's this little angle here. So tangent of that angle is opposite 12 over, whoops, tangent theta, 12 over 5. Anyone have that? 6738. Oh, 1. That's that little angle in there, right? And then this will be the y of the 25. This will be the x of the 25. So we just need to find a space of the paper and figure those out, do our trig, right? So the triangle I'll build is over here using that angle. So I can say the sine of the 67, and I'm not going to write the 3/8, but I'll use it, is going to be the y of the 25 over 25. Okay. So that's using this little triangle over here. Basically just placing this over here to build the triangle. So y of 25 equals. So 230769. And that's going down. So then the x is just the cosine, same thing, cosine of that 67. Not going to write that formula. Should be good with that by now. 9.61. 54. And that points that way. Anyone struggling with that? Do we feel like we got that? As long as we keep our directions good. All right, then we need to do the other one. I'll build the little triangle on this side. Still gets applied here. And I'll use the 75. That's 75 degrees. Yep.
Yep.
So I will say sine of 75 is going to be that y of 15 over 15. Y 15 equals 14, 4, and a lot of 8s. And it is going down. And the x, 75 cosine times the 15. 3.8823.
That's good. Right.
That is going to the right. So drawing them in is important because it's going to give you your direction, right? So this one's going to the right, this one's going to the left. Both of these are down. So I would definitely redraw it after I found the components. Takes very little time to redraw. Eight feet. This is our point O. Roll her out here. The 25 is here, so this is the 23.0769. This is the 9.6154. This is the 14. And 3.8823. So getting rid of the angle forces just makes your moments a lot easier. It's a lot of work and it, opportunities to make mistakes. So you just got to kind of grind through it slowly, but that's your problem now. So now we do what? Moments at O. Yeah. Pick a spot, sum your moments. They just gave us point O, so we'll use that. be, I just go left to right, so I don't miss anything. 10 K times 8 feet. Rotation. Negative. What about the 3.8823? Does it create moment? We're doing moments. You could add these two together. Is that what you're saying? Free? Yeah, so when you're doing moments, this goes right through the point. Right? So it creates no moment. The moment of that force about O is 0. So I could put it in, but it's 0. So just, you can leave it out. How about this one? Same thing. So the X forces drop out. They do not create moment. Going through straight through the point you chose. It's like your finger on the door hinge. You're not going to open the door that way. You got to get the force away from the rotation to get rotation. So these two go right through the point, no moment. The only moments are the 10, the 14, and the 23. So 14.4888 times what? Yeah, that was 8 and 6. Right? 14. This is 6 feet here. This is 5 feet here. Rotation of the 14. It's going to be clockwise. Clockwise is negative. And then 23.0769 times 19 feet. Negative.
That's. So those two forces that are going there, like if this was a door, that's almost like if here was the hinge, like pushing on it right here.
Yep.
Okay. So
Yeah.
that's-
Yep. It's like if you had a pole that is supported like this, right? Straight up and down, and it has a weight. So you push down on the weight. It's not going to rotate, right? It just sits there. So that down force right here doesn't create any rotation. If I go like this, it's definitely creating rotation, right? So, and at any angle, it creates rotation. But if I point straight down, no moment.
Yeah, that makes sense.
All right. What do we get for a moment at O? 7-0.
7203043.
Where's the point?
Oh, add 0. Yeah.
Yeah, so give me the numbers again. 721.30556. Agreed? Aaron? Oh, surrounding.
I took an extra that off number, that's probably why.
So it's just rounding. Yeah, okay. And our unit is kip feet. All right, now what? Sit in front.
Is that right on the 23.0769 times?
I think so, yeah. Yep. We have the moment.
Find the distance away.
Mhm. You jump in a step. Yes, you got to move all your forces, right? So if this is my beam, I now know I have a moment here. I'll just call it moment at A. That's this. Or O. Not A. Right? But I need all the forces there. Got to collect them all. So there's going to be a total down force. That's going to be 10, 14, and 23. $47, 5657. 47.565 rounds up to 8. Okay, because that's a force, right? And then what about my X forces? Got a negative 96154. And we have a positive 3.8923. Given me a negative or pointing left. 5.7231. This can be drawn right here, like this. And then you can see R is in here somewhere. So it's nice to draw your components either arrow to arrow or tail to tail. This one could move down and it could be there, but that would position R in the same position. So however you draw it, make it either tail to tail or tip to tip, and it'll give you the location of the resultant. There's the resultant. This is this force, the X. It's called Rx. This is called Ry. They're the components of the resultant. The X and Y components. So how do we get R? Pythagorean theorem. Just square them and add them up. And when you square them, the signs go away. $47,9088. So R equals 47.9088. I'll just carry those for now. And that's Kips. It's a force. It's here. Right? So I'm getting closer to my answer. At least I know the resultant, right? I know the resultant magnitude. I don't know the angle yet that it acts at because it's at an angle. So I should get that. This angle right here. How am I going to get that? Yeah, just kind of set the Y force over here and then do tangent Ry over Rx. So tangent, I'll call it theta, is Ry 47 point over Rx. You don't need the sign in there. It's just side and side, right? So theta equals what do we get? 83? 83.19. So that's good. We got the angle, we got the resultant. What else do we need?
Distance.
Yeah, where is it at? We know it's out here somewhere. At an angle, which we just figured out to be theta, that thing. But we need to know where it is distance-wise. So we know it's moment divided by force for distance. This is where you got to see that that x component is going right along this point and just does not contribute to the moment out here. So this moment is completely generated by the y. So when you have a force at an angle, you're going to divide by the y component of the resultant to get a x distance. So the moment was 721.3056. And we're going to divide by the y component 47.5658. Okay, and kept feet, and that'll give us feet.
You get 15.6343.
Well, let's see. Sounds right. It's on the beam. It's where we thought it would be, kind of centrally located. Yep. 15, so be 15.16 feet right of O. This I would end up rounding to 47.91. .83 degrees with my symbol locating that angle and a distance. Just that easy. But yikes, that was a long one. That's definitely as tough as it gets on the midterm.
Forgot to add in like X forces back in, like I took them out, but then I
Yep.
forgot to put them back in.
Yeah, it's easy. That's easy to do.
So I got like a slightly less because it wasn't very. But
Yeah, no, the X is pretty small, 5 compared to the 47.
But it's
Yeah. You just have to remember to do, if you have the X and the Y, you have to do Pythagorean theorem to get R. So I do that first because that gives me a big part of the answer. I know what the resultant is, right? Then I work on getting the angle and the distance. But really, for strength of materials, we're going to use the X and Y. We're going to use this and this. We're not even going to deal with R because the Y force is what's creating all the bending. That's what's creating the moment. And that's what we need in strength of materials. So really, once you get to the components, that's priceless. Like that's what we use in the next level of the problem.
when I had a brain. I was wondering where it was like, I just had the components and I didn't have the result. And it was just like, oh, I don't have the answer. I started erasing. I'm like, wait, no, you have the answer.
Yeah, that's a big part of the answer. Yeah, it's just Pythagorean theory.
Yes.
Yep. Excellent. You can hang on to those if you want them for the midterm, and then just turn them in with the midterm on Friday. Any questions before I just start into a little review here? Huh?
I had something.
Okay, well, this will probably bring it up. We'll probably find it. We'll find that question. All right, chapter 1 really just started with some very basics. Like, what are the applications of statics, numerical accuracy, dimensional analysis, which is just having units in your numbers. So chapter one's really not, I wouldn't spend a lot of time on chapter one, right? I'd move straight to chapter two. We did talk about forces in the very beginning, right? And that they have 4 characteristics. Can you name the 4 characteristics of a force? I would never ask you that because you're using your book, you can just look it up. But if you can like name them without looking at anything, at least kind of work your way through them, that'd be good. So tell me about this thing. What do we know? Direction. So direction is either the angle or whether it's going up or down, right? So direction is the angle, theta, right? And direction includes the line of action. Direction, like if this said, 60 degrees, it doesn't tell me, 60 degrees doesn't tell me whether it's going down that line or up that line, right? It just gives me the line of action. What's another one? Magnitude is this length, right? That gives me the magnitude, like 400 kips. The length of the vector. Good, we have direction, we have magnitude. Sense, that's the arrowhead. This tells me whether it's going up the hill or down the hill, right? The angle does not tell me that. And the last thing, the 4th. I'll give you a hint. Yeah, point of application. Where is it being applied to? Like it can be like this too, right? Point of application is there. Those are the 4 things. That was like chapter 1. Or chapter 2, sorry. Chapter 2 talked about types of force systems, and we've only done 2 types. Those are the 2. What's this one called? Concurrent. And this one? Yeah. It's the only 2 types we did. The only 2 types you have to worry about. But we got to be able to find the resultant of this one and the resultant of this one. That we just practiced, right? And we just did homework sets on it, like 3 of them, a week of it. So you'd like refresh your mind on how to do the vertical one and the horizontal one. Right? But we practiced those, so, and that's recent. What we haven't done in a while is this. So we have to go back in time and kind of remember what was different about this than this one. Concurrent and non-concurrent. What do we use here that we do not use here? Yeah, moments. So this is where we introduced moment equals force times distance. But this has no moments. All the forces come through one spot. So there's no rotational effect. So even if I give you this thing on a beam, don't go summon moments. You don't need to. All the forces are here. Where's the resultant at in this problem? It's here at A. It has to be. All the forces are at A. So look at the force system and go, oh, that's a concurrent force system. I know the moment is zero because all the forces go through the same spot. It would be force times zero, force times zero, force times zero, right? And that the resultant's got to be here, and it's just the collection of those forces. You get this one, then you're like, oh, forces at a distance. I definitely have moments. I have to go through the whole process. The other thing we did in chapter 3 was components. Chapter 2, was it 2? Vector quantities, principal address. No, it was chapter 3. So chapter 3 talked about if you have a force on a system, that the effect of that force is exactly the same as the effect of the components of that force. We just did that in this problem. We got rid of the angled forces and put in the components. So this Y force and this X force create the same exact effect as the 400 newtons. So the problem gets simpler when we get rid of the angle forces and put in X and Y. That was Vergenon's theorem. Again, I'm not going to ask you like, what's Vergenon's theorem? Because you can just look it up, right? But you should know that the components can replace the angled force. Nothing's changed. Okay. So we find components a lot. That's how we solve this problem, is we find the components to every force, add up all the components into Rx and Ry, and then Pythagorean theorem the resultant. That's it. 3 chapters. Piece of cake, right? What could be
It feels like
confusing?
So much when you're going through it. But then
What gets confusing is I give you a really like a busy problem. I won't say a hard problem, but I'll give you a busy problem, and then I'll ask you to do simple things with a very busy problem. So you could get something like this. I was making this up.
Yeah, when first that was like the billboard. It's like, now it's just.
Right, and then I don't know, give me some loads. 40K, that's a big one.
We can't see any of them.
Why not? Oh, that's disappointing. All right, we'll do this as our practice problem. I'll let you capture it. We need more information here. 10 foot is all the way to C. And this is 7 foot. Yeah. So the distribution is 7. Got it? So I could ask you to find moment about point C of the distribution. Right, so I just ask you one maneuver or one part of a bigger problem. So you'd have to know what the distribution is. Like, what is that? That's the 10 kip per foot. And then point C, where's that? That's here. So let's do it. You do it first. I'll do 2.
Angle 70.
Yeah, the 20K is 70 degrees. Got it? Getting it? Okay. Better double check my answer. All right, what do we do first? Area of the triangle. So that's 1/2 the base, which is 3.5. Right, half of 7 is 3.5 times 10. 35. Where's that get put? Yeah, 35 kips. 1/3 from the 90. So 1/3 from here, 2/3 from here. And we're going to point C, so we need 2/3 of 7. Right? That is 4.66. feet. But that's just to here. Right? And then there's another what? 3 feet. So that's important for our moment.
Yeah, that's what I'm trying to figure out. Settings.
Yeah, so it's from the 35K, it is 3 plus the 4, that's 7.6666 to get to C. So the moment is going to be, and this is of the 10 kips per foot distribution, 35K, the concentration, times 7.6666 feet. All right, from here to here. Rotating counterclockwise around C, positive.
Oh, the distribution.
The distribution. Yeah, that'll happen on the test.
I mean, I found that.
You were just going for it, right? You're just working
Yeah,
the problem.
I was
Yeah.
looking at it.
So I'm trying to help you by not making you do the whole problem. I just make you do pieces, right? I might have you do the whole problem on one of them, but most of them are not going to be whole problems. They're going to be a very specific thing. Find the moment of the distribution. End.
Did you figure out the 1/3?
So you guys just got to know that it's in the book. So if you don't know it, you have to look it up for the shape. So really all we've done is, yeah, it's a little chart in the back of the book. And we've done a few triangles in class, so we've talked about it, and I can't find it right now. Maybe it's in the, oh, there it is. Yeah, it's in the very back. Nope, it's in the very front. Triangles and rectangles are all we've done so far, so it'd be pretty evil of me to give you something else. But we will be doing some curves, some parabolic curves. Wow, why can't I find it? Oh, maybe it was that one in the back. Yeah. See the right triangle though. Why they don't have the right triangle back here? Yeah, I guess you just gotta know it from being in class, I guess. From the discussion, yeah. It's the way to remember it, you know, definitely make some notes so you have it during the test, but the way I do it is I find the 90, right? Wherever the 90 is, you know, it's 1/3 the base. to that force. So that means it's gotta be 2/3 out here. And it doesn't matter the position, right? It's always from the 90, 1/3. So the other thing I could ask you is find, like, I can build 4 problems out of this one diagram, right? Find the y component of the 20K. So you're given this big problem and then it just says find the y component of the 20K force. So don't be cranking out a bunch of moments and
Tell you that right now.
and finding the resultant. Yeah, because you already did it. Exactly. It is important though, don't turn a 5-minute problem into a 40-minute problem.
Totally, yeah. I mean,
Yeah,
where-
that'll kill you on the test, because there's 10 problems. So there's not room to work every problem all the way out. And I'm trying to help by just having you do one thing for the 10 points type of thing. So what would the y component be? How would we do it? Sine 70 equals, because that puts the y component here, opposite y component of the 20K over 20K. Yeah?
Yep.
Y of the 20 equals, you can do the math. Yeah, so just really read the problem carefully. And you don't need to do more than that. I don't penalize you for doing more. I'll probably make a note, like, didn't need to do all that, right? But yeah, just save yourself some time and just, I could ask you to do the moment about C of the 20 kip force. So yeah, there's all that. And then these, remember, these problems, the concurrent problems, if there's 2 of them, what are our options?
Components.
Yeah, you got components. And what's our other option? Triangle. Yeah, you can build a triangle. So you should know both methods. I haven't completely built, and not normally, like if you can get the resultant, I don't really care how you do it. So I'm gonna kind of review both, but. So the triangle method said this parallelogram, you can build a parallelogram, right? Because you add the forces together, this one here, this one here, and that gives you the resultant. So the parallelogram says you can build this parallelogram and there's the resultant, and then you can make these triangles by putting this one here. And then trying to dig out some internal angles. Like that's 40, so this is 50. Right, because this is 90. So the triangle method means build a triangle out of the 2 forces. If there's 3 or 4 forces, then we're not going to use the triangle method. We're definitely going to do components. Okay. So if I did the triangle method, I would then pull it out. Like once I got my triangle, this is busy. So then I just simplify it into R /60 80 and 50 degrees. Once you have that, then you have a non-right triangle, often non-right triangle. And you just have to remember your trigonometry for non-right triangles. We have sine law, we have cosine law for non-rights. Sine law, you need an angle and an opposite side. You gotta have that to run it. And do we have an angle and do we know the opposite side?
Oh my gosh.
Because zoom tight times 3. 50 and R, but we don't know R. And we don't know these other angles. So you're not gonna run the sine law.
You could cosine law.
You'd have to run the
Side,
cosine.
side.
Yep. Side angle side triggers in my head cosine law. And the fact that we just don't know an angle and an opposite side. If you don't know both of those, angle and opposite side, you cannot run the sine law. So that means cosine law, and that was the c squared equals a squared plus b squared minus 2, yada, yada, yada. So this is c right here, so I'll just write it r squared equals a squared, either side doesn't matter, plus b squared, 60 squared, minus 80, 60. Isn't there a 2 in there? 2, almost forgot the 2. And then what? Cosine the opposite angle, which is the 50 degrees. So you do have everything to run the cosine law to get R. If I ask you to find the resultant, then I do want the resultant and the angle typically to horizontal. So once you get R, now you know this side and the opposite angle, you can run the sine law to get this angle, then subtract it from 90 to get that angle. So once you get R, then you can go use the sine law to get the rest. It's a little easier. Anyone get R?
61.
Anybody confirm?
Squared.
Yeah.
I got it. Non-squared, it's 3,829.
I get 6180.
But.
88 pounds. Yeah.
Would that be that little angle horizontal?
Yep. Right there. I'll take any angle, whatever angle you give me for R. Like if you find it to vertical, I'm okay with that. But the common thing is to go to horizontal with your result. So yeah, so now that we have that, I can set the sine law up. So the 61.88 over the sine of opposite 50 equals, and then I would use the 80 over the sine of, we'll call it alpha. Because once I get alpha, I just take it away from 90 And I got theta. Right? Because we know that's a 90. So then I gotta solve for alpha. Never find my 1/. Anybody get a number? Yep. 82.0384. 82.04 is enough. That's that one. And then if I take it away from 90, I get theta equals 7.61. 7.61. So if you got two forces, you can do triangle or components. Components would have worked, just you would have had to found the x and y of this one. That's already just a y component. Add them together, find the resultant, Pythagorean theorem, find the angle. So either way, it's money. Questions? All right, I think you're pretty much it. All those concepts. That's what will be on the test. Again, you can come early. I'll be here at 7. You don't have to come that early. But if you want to early start and get the full 3 hours instead of 2 hours, you can come early. You won't need it. I don't think time's going to be a huge factor unless you just don't read the problem and work every problem like all the way out. Then time could become a problem. So